geometry. So this lesson is 1.2 points, lines, and planes. So the first idea that we're going to talk about are points. Now this stuff is going to seem real basic when we first begin because it's the very first section that we're talking about. Okay, so points. What do you already know about a point? Anybody? I like a lot of interaction. Yes, sir. It's like a dot. Great. Yeah. So here. So is that a point right there? Yeah. What about this? Is this also a point? What's the difference between those 2 points? One's bigger, one's fatter. Does it matter? No, doesn't matter at all, right? Doesn't matter. So, okay, this is a point, right? And a lot of times we're going to label points. We're going to call that point what? A, good. What do you call this point over here? Aha, yeah, see, so it doesn't really matter. It doesn't need to go in any order. They have no size, right? It's just, it is what it is. So there is no size associated with these points, and it's represented by a dot. So, okay, let's talk about lines then. So, what do you already know about a line? It goes on forever. In which direction? In both directions. Yeah. How do I know that this particular object that I've drawn is a line? What makes it a line? What do you think? Yes? Yeah, the arrows tell you it goes off into both directions, right? So it extends in 2 directions, and it has no end, right? Does it have a thickness? How thick is this line? Does it matter? No, just like a point doesn't matter either, right? But we have to label this thing, and so if I put this L here, what would you guys call this? This would be line L. Yeah, very good, right? Okay, there's another way that we could represent a line. And if I have a straight line and I've got 2 arrows over here, let's say I have a point, 2 points that are on this line, and I call these points A and B. So point A and point B are actually on our line here. So I could label this as this. I could label this as line AB. And I would put a little line above the AB that extends in both directions. Make sense? Easy enough, right? Could I also say this? Could I also say that this is line BA? Is this also correct? Yes or no? What do you guys think? Yes. It is totally correct. Doesn't matter which direction we do it, right? So we can label a line either AB or BA, or the line that it's called, line L in this case. Alright, a plane. So when you think of a plane, what do you think about? Just a couple different things you can think about. What's on your mind when you think of a plane? Not an airplane. What's that? A coordinate plane. I like that. That's true also. How about the desk, the top of the desk? Is that a plane? Yeah, kind of, right? But that has an edge to it, right? Would you say that? The desk has an edge? Okay, planes don't have edges. Yes, sir? Yeah, planes. What's that? Yeah, they're just like lines, right? They extend in all directions infinitely. So they don't really, even though I've drawn this picture with an edge, right, it doesn't really actually have an edge. And notice that there's a little M here, so we could call this plane M, right? Or whatever it is that I would be calling this. So we're talking about all the space, all the infinite amount of points that are inside this plane right here. So a couple of points about a plane. One, it extends in all directions. And it has no thickness. No thickness. When you think of space, when you see the word space, what comes to mind? Now, I know we're in a geometry class, but what do you think about space when it comes to mind? How would you define it? Yeah, what do you think? Outer space. Outer space. I like that. Anything else? Emptiness. Emptiness. Okay. Space got emptiness. All right. What else? Anything else? You're all on the right track. Yeah, what do you think? Infinite? Yeah, okay. Like a line is infinite? Yeah. So there must be a difference, right, between a space and a line, right? So, but you're on the right track. So for us, space, we're going to say that this is going to be the set of all possible points. Now think about that, right? If you think of every point you could think of and put it together, you get space. All possible points, all right? All right, collinear points. What do you think collinear? Put the 2 words together, collinear. What do you think? Yeah.
They're like 2 points that are in one.
Yeah, exactly. Okay. So this is points, all points on the same line. Okay, so collinear points means points that are on the same line. There could be 1, I mean, sorry, there could be 2, 3, 4. How many points could there be in collinear points? And there's an infinite amount, right? They're all the points on the same line. What do you think non-collinear points are? They're not. Yeah, you got points not all in one line, right? Points not all in one line. All right. Okay, what about coplanar points? What do you think coplanar points are?
On the same plane.
Points all on the same plane. You got it. Points all in one plane. Okay, here's what I'd like you to do. Okay, take a look at my little drawing down there. So what is that drawing? What does it look like to you? It looks like a cube. Yeah, okay, I like that. It looks like a cube or a box, right? Could you name 2 points that are collinear? Give me, yeah, what do you think? A and B. Okay, hold on, let me, let's do this. So I'm gonna highlight this. You say A and B. Can everybody see the highlights? Does that make sense? Are those 2 points that are collinear? What makes them collinear? Yeah, same line. Okay, good. Give me another set. C, D. C and D. Good. Give me another set. What I hear? E, F. E, F. Okay, good. Okay, these are all correct. What about these 2? What about G and D? You would say no, right? But what's the real answer, guys? Yes. The answer is yes. Can you draw a line that would contain those 2 points? Yes. You sure can, right? So any 2 points are what? Collinear. You think about it. Pick a point. Any point in space. Pick another point. Can you always draw a line between those 2 points? So any 2 points are collinear, right? That's a good thing to talk about. Okay. Non-collinear points. Can we find any of them like that? You need 3, right? What about E, F, and B? Yeah, that doesn't work, right? E, F, and B would not be non-collinear because they're not all on the same line. But what about E and B? Those would be, right? You see the difference? Okay, that's a big difference. Okay, good. Give me coplanar points. Points that are in the same plane. They're all in the same plane? Say again? A, B, C, D. Those are all on the same plane, right? If I thought that, if you look at the, what could I do here? How about blue, right? So the front of this being like a plane. So this is the plane extending in all directions. So is E, point E, in that plane? No, it wouldn't be, right? That point E would not be in that plane. Okay. All right, what have I drawn here for you guys? What do you guys see? 2 what? You just see 2 lines, right? I have drawn 2 lines. And if these 2 lines intersect, what do they form? They form a point, right? So we'll call that B, point B. So 2 lines intersect to form a point, right? That makes total sense, all right? Now, what if I give you a line, and I'll call that line L, and I give you a point on that line, which we'll call B. All right, how do we use the terminology to describe this? Any thoughts? What do you think? Yeah.
It's line L and point B is on line L.
Yeah, that's one way we could say it. We could say B is in line L, right? We could say B is on line L. We could say that L contains B. L contains B, so L is a line that contains point B. We could say that. Or we could also say this. We could say L passes through B. Through point B. All 3 of those are totally fine. We could say B is in L contains B, or L passes through B. All of those totally work out just fine. So far so good? Cool. All right, cool. Let's talk about if I drew a plane for you then. All right. So here's the plane that I'm going to draw in purple. And I'm going to highlight it like this. And I'm going to call that plane B. Then I'm going to draw a line. Now the line comes up, and then I'm going to draw dashed lines to there, and then I'm going to draw a solid line to there and keep going. Why do you think I do that? What's going on with that? The diagram there. Why did I dash it? Yeah, it's going straight through it. The dashed part is the part that is behind the plane. Does that make sense? It's behind the plane. So if I have a line L and I have a plane B, what's one possible intersection I could have here? How do they intersect? What do they make?
A line.
No, they don't make a line.
A point.
They make a point. Yeah. So right there, they make a point. And we'll call that point C.
Could the point be anywhere on the plane?
The point could be anywhere on the plan. Yeah, sure could. Could I draw a plane that contains a line? Okay, go ahead. See if you could draw a plane that contains a line right now. All right, so I'm going to call this plane B, and I'm going to call this plane A. Okay? So if I have two planes that intersect, do you think you could highlight where they intersect?
No.
Yeah?
Yeah.
All right. Do right now. Do it in your brain. Highlight where they intersect.
Do you need to draw this?
Yeah, if you can, draw it, right? It is an advanced drawing. All right, so I have two planes. I have plane A, I have plane B, and they intersect. If I have two planes that intersect, what do they form? What do you see? They form a line. Exactly right. They form a line. So when two planes intersect, they form a line. Right there, we can call that line, if I call this point X and I call that point Y, that'd be line X, Y, and it'd be written just like that. So the intersection of two planes would be a line.